Alright, so welcome to my Concepts of Algebra 2 kids. This is your review for your 7.1 through 7.3 and 7.6 quiz. That'll be happening on Thursday. One of the last few big grades of the 9 weeks. So hopefully this helps you prepare. Again, write the problems down, do them before I explain them, and then bring them into class. And that'll be a great review for your quiz. Alright, so here's the first problems we're going to work on. A couple of solve the equation. Now, in these problems, you're going to have an exponent. So here we have the fifth power. Okay. What is being raised to that fifth power? Well, only the x is. So let's get the x by itself. Let's get rid of this 2. Divide by -2. So that gives us x to the fifth equals -32 division. And now, to get rid of the fifth power, we're going to introduce the fifth root. And if I do it on the left side, I have to do it on the right side as well. What happens is the fifth root and the fifth power cancel. And you get x. Now over here, you have to use your calculator. Remember, you put the index in first, second, and that caret button gives you the x root, and you put -32. And because this is an odd index, you're going to get one answer. One answer, and that answer comes out to be -2. That's it. Now, over here, here is a fourth power. This x minus 3 is being raised to the fourth power, so we need to get that by itself. Well, there's nothing else over here with it, so it already is. So what I'm going to do to get rid of that fourth power, I'm going to take the fourth root. 4 through this side, and I have to take the 4 through that side. So what happens? The fourth root and the fourth power cancel, and I get x minus 3. Parentheses can drop because the power is gone. And when you take the fourth root, an even root of 625, the calculator says 5. But even means 2 answers. So now I have 2 problems I need to set up. X minus 3 equals 5, and x minus 3 equals -5. So notice it's the 5 that I break apart because it's positive and negative. And I get 2 answers. Add 3 to this one. 3 plus 5 is 8. Add 3 to this one. -5 plus 3 is -2. And there's my 2 answers for these solve problem. Okay, here's our next problem. This problem says evaluate using radicals. Okay, evaluate using radicals. And you notice that this problem, 216 to the 2/3 power, has no radicals. But you need to remember that relationship. We can rewrite this in radical form. The denominator, this 3, becomes the index of the radical. Third root. The big number stays big, 216 inside. And that entire thing is going to be raised to that numerator, the second power. So now it just turns into a calculator problem. The cube root of 216 should come out to be 6. And we do that in parentheses, and we square it. Make sure that parentheses is very important. And we square the 36. We square 6, and we get 36. And there we go. And that's how we use radicals to rewrite rational exponents. Okay, here's our next problem, and this is gonna have all of the exponent rules in it. So pay very close attention. Right. Give me 1 second. Let me change this. One quick thing I want to change, and then it'll have all of the rules in it. Okay, so if you notice, I added a y to the 12th on the bottom. All right, so I made this very complicated, so we'll walk through it very slowly. Okay, this is a simplify using the exponent rules. Okay, so exponent rules. So we're talking about product of a power. We're talking about our product of powers, negative exponents, all that stuff. So you have those 7 rules. So the first thing I would do is this 2/3 needs to go inside, and it's going to go to everything in here. There, 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 and there. So 1, 2, 3 things. And when we bring it in there, we're going to be multiplying the exponents together. So over here, let's do our scratch work to the right. And below, we'll write down what we get. So the first thing we're looking at is this x on top. Okay, and I'll draw this bar. So we're looking at the x on top. It's going to be 6 times 2/3. Well, remember we can put 6 over 1. That's 12 over 3. 6 times 2 is 12. 1 times 3 is 3. And this is 4. There's the exponent of the 6. So right now what we're doing is we're doing a power of a quotient. So the rules we're using right now are power of a quotient. And then when you get the power, you are raising it to another power. So we're also using power of a power. So those are the two rules you're using right now. So we did the x. Now let's look at the y. Okay, so we have negative 3 times 2/3. Again, put the negative 3 over 1. That's going to be negative 6 over 3, which simplifies to negative 2. So this y, negative second power. Next, x to the third, the x on the bottom. 3 times 2/3. Put the 3 over 1. 3 times 2 is 6. 1 times 3 is 3. 6 divided by 3 is 2. So notice it's the same problem, just one was negative, one was positive. So this x is to the second power. And the y to the 12th. 12 times 2/3. Put the 12 over 1. Multiply straight across. 12 times 2 is 24. 1 times 3 is 3. 24 divided by 3 is 8. So we were lucky that all of these exponents simplified. So that's the first step. Next, I'm going to use negative exponents. This right here, that's a negative exponent. It's got to move to the bottom. So the x to the 4th stays up top. The bottom stays the same except for we now bring that y to the negative 2nd. And when you bring it to the bottom, it turns positive, squared. Okay. So that was the negative exponent property. Next, I'm going to do two things. With the x's, this is going to be a quotient of powers. Quotient of powers says you subtract 4 minus 2. And you get 2. So that is the x on top. Now on the bottom, these y's, they're on the bottom. They're being multiplied together. So now we're going to use a product of powers. Product of powers says you add 8 plus 2 and you get 10. And that's the exponent of y on the bottom. And that crazy complicated thing turns out to be x to the x squared over y to the 10th. So again, you must know all those rules. And like I said, 1, 2, 3, 4, I almost got all the rules. I got 5 out of 7 on this one problem. So this was to really show you how to use these exponent rules good. Okay, here's our next problem. We're going to simplify the square root of 81 x to the 4th y to the 10th. Now, what we need to understand is for things to come out of this square root, the index is 2. So you either have to have something squared or something written twice. Let's write out everything we have. Now, 81, I think it's two numbers multiplied together that are the same. I think 81 is 9 times 9. Now, this x to the 4th, there are 4 x's. And this y to the 10th, there's 10 y's. That's 1, 2, 3, 4, 5, 6, 7. That's 10. So that's all underneath this square root. So the idea is for every 2, 1 comes out. So that's bad. There are 2 9s. So a 9's going to come out, and they both go away. Let me use a different color to illustrate this. So here are the 2 9s. And for every 2, 1 comes out, and they both go away. 2 x's, 1 comes out, they both go away. 2 x's, 1 comes out, they both go away. 2 y's, 1 comes out, these 2 go away. 2 more y's, 1 comes out, these 2 go away. 2 more y's, 1 comes out, these go away. 2 more y's, 1 comes out, these go away. 2 more y's, 1 comes out, and these 2 go away. Now, notice I crossed everything off, so the radical disappears. Now, if something was left inside, you'd have to leave the radical, but there's nothing. And now let's just simplify this. all these x's and all these y's, we can write this nicer. The 9 stays alone. X times x is x squared. And y times y times y times y times y, 5y's y to the 5th. And there's the simplified radical. Okay, so let's try this problem. We're going to have to solve the radical equations. So in this problem, we say 4 times, this is 4 times, the 4th root of 81, or 8x plus 9 minus 12 equals 0. This is the radical which must be isolated, or get it by itself. So two things. There's a times 4 and a minus 12. Always do adding and subtracting first when undoing things. Work backwards. So we add and subtract first. So this is 4 times the 4th root of 8x plus 9. The 12's cancel, equals 12. And now, to get rid of this times 4, let's divide both sides by 4. And the 4's cancel, and we get the 4th root of 8x plus 9 equals, and 12 divided by 4 is 3. Now, to get rid of this 4th power, we are going to introduce a 4th root into, not a 4th root. To get rid of this 4th root, we're going to introduce the 4th power, right? You raise both sides to the nth power, and your n is 4. So that's going to cancel out the radicals with the exponent, and the 8x plus 9 drops down. And over here, 3 to the 4th, use your calculator, is 81. Now let's just get x by itself. Subtract 9, 8x equals 72, and divide by 8. And we arrive at our possible answer of 9. X equals 9. Now we are not done until we check. So let's do the check over here. You always got to check by plugging in 4 times the 4th root of 8 times 9 plus 9 minus 12. This should come out to be 0. Well, let's simplify in here first. Do this in the calculator. 8 times 9 is 72, and 72 plus 9 is 81. That's inside that 4th root. 4 times the 4th root of 81 minus 12 equals 0. And now we need to simplify. The 4th root of 81 is 3. 4 times 3 is 12. And 12 minus 12 is 0. So this is correct, so we can square that answer. It's fine. We can box it. That's a good answer. All right. And there is the solution of this problem. So get the radical by itself, raise both sides to the nth power, solve for x, and then check your answer. Okay, let's try one more of these. One of the more difficult ones.